Hello, my name is Connor Cunningham. I work for Microsoft. I'm an architect on the Azure Data team. I've been at SQLBits for a number of years now. I'm excited to sort of be here this year, although I kind of wish I could see everyone in person. I am going to give a talk today on sort of modern data application patterns, do's and don'ts, if you will, based on a lot of the experiences that I have, and I hope that you enjoy it. All right. One of the nice, fun parts of my job is that I get invited to go talk to companies about how do they do design, application development, figuring out sort of the strategy for how they're going to develop their data-centric applications. And so when things go well, I get asked ahead of time, and we go help a company come up with a strategy and execute on it. When things go poorly, I sometimes get called in after maybe an application has gone live and things didn't perform as well as expected. And so I get a lot of opportunity to look at a lot of different applications. And after a while, you start to see patterns. And one of the neat parts about this job is that all these just come to us every day. So Microsoft is such a great company because it has scale that I get to see applications, good and bad, every day and help lots of different companies at scale as a result. So whenever I go talk to these companies, maybe on the bad days when things aren't going well, they often want to know, why did the software not work as intended? And often the design choices that were made far, far earlier were the things that got in the way of success that day. Likewise, whenever you do the proper decisions early upstream, then you basically have non-events later, and life is good. So there's a lot of things that you can learn from kind of just watching the life cycle of applications and the genesis of the ideas that people use when they decide that they're going to try something new. And sometimes those work really well, and sometimes they don't work so well. So we have a number of different things that I'll go through in the talk, various examples from both first party and third party companies with whom we work. And then on top of that, this conference was originally supposed to be earlier in the year, and obviously it got postponed, and now it's virtual. But one of the things that I was able to add to this talk was during the time that we were supposed to be giving this conference in person with you, the the internet was going crazy, and there were a lot of opportunities for us to go and see what happens when you have a response to a pandemic and how does that affect online services. So I'll talk a little bit about what we do internally and what we had to do to survive the COVID-19 surge in demand that came towards SQL and other parts of the Azure Data business. So whenever you use the term modern, it's a loaded discussion, but I will try to sort of lay out the general trends or properties that I see whenever we talk about modern applications. And modern can mean different things to different people. And just because I have a particular thing written on this deck doesn't necessarily mean that every single application must do all of these. You can definitely have applications that don't follow every single one of these trends. I write them down mostly as directional statements, meaning whereas there would have been certain properties 20 years ago or 10 years ago in terms of how you build a data-based application, they're less likely to be the case in some cases and more likely to be these newer patterns that I'm describing. So historically, when databases first came to be, they were often descendants of mainframe systems and other ISAMs, which had essentially cursors as the only model. They didn't even have query languages. So a lot of early applications are very heavy with cursors, and there still are a lot of applications today that do use cursors. The default mode in SQL actually is to be a fast forward cursor, although it's not really a cursor in any programmatic sense. It just happens to be the nomenclature that was used at the time to describe the functionality. Going one step further, if you say, okay, I need to go do lots of trips to the server in order to move state around, then obviously you have a tight coupling between whatever your application is and whatever the database is. And the more you do that, that eventually will make it harder and harder for you to scale or to have better concurrency. So ultimately, when you start from that pattern in the old days, what do you see more of now? Well, people typically will do logical paging patterns where they'll use row number or top with offset and limit to say, for this query, give me the next 20 rows. And that way, in between calls to the first page and the second page, the server doesn't necessarily have to have any state for that application to be successful. So it allows you to have a looser coupling than what you would have had in the original models that we saw back in the day. Furthermore, kind of extending the theme, often if you have very chatty applications with multiple batches per around per transaction. This often also leads to tighter coupling models, where if you had a cursor, you obviously would get fetch next, and that's a round trip across the network. In this case, same idea for how do you make sure that you get whatever general operation that you're doing is better if you can try to get it into one request or one batch so that the server can process it, finish it, and then be done. And that means that it's easier for you in your application to be able to reason about restarting from wherever you left off. If the server goes away or the network has a blip, that makes it easier for you to recover if you have that property in your application design. Also, chatty applications often have network scaling issues, especially if you try to move them to an environment different than the one you originally developed it in. So if you try to go onto a cloud provider, you might find that having a really chatty application can make your application almost unusable in terms of the performance impact and overhead. Going one step further, large transactions, same basic idea. If you have the option to split it up into smaller ones and to be able to recover and retry, that usually makes it easier for you to build an application that doesn't have that tight coupling. Now, there are examples here where, say, if you do bulk insert and you can recover, just start over, it can still be a large transaction in that case. But ultimately, you want to try to make sure that you can reason about the operation. And if you have to start over, it's not going to mean that you miss your SLA for your maintenance window, for example. We've added functionality in SQL 2019 with accelerated database recovery, which does make it easier to have faster failovers, even if you have larger outstanding transaction state that needs to be rolled back. However, it's still generally beneficial to avoid having large transactions, because if you have, you're basically versioning pages when ADR is in motion. So that means that if you have a very, very large transaction, you can run out of disk space on some of the cloud SKUs that are there before your transaction can commit. We usually see mostly three-tier application patterns, meaning you'd have some sort of app server, ASP.NET kind of application, or J2EE. Similar kinds of patterns are the norm, rather than tight coupling of a client application directly to a database. So modern applications usually will have that disconnect, and that tends to lead to connection pooling, fewer cursors, less state being held, because ASP.NET and similar don't hold state usually in between calls to the database. They can, but sessions are usually ephemeral in that world. And then finally, we've seen trends that depends a little bit on how you want to build a database application, but sometimes people will put everything in the database, and all the procedural logic, all the business logic. It's usually the case that the business logic is held in a tier above the database for most situations. And in that world, maybe you can see extreme versions of this where people try to put no state whatsoever of any interest in the database, or they go completely to a NoSQL pattern and just use get put patterns completely. And depending on how far down that path you go, you can get to different outcomes. And I'll have an example later in the talk of where that can go sideways. So we've obviously been going through a transition in the industry from when you typically would buy your own hardware to where often you go and rent your own hardware by using a cloud provider. That doesn't mean that every application will be in the cloud, but it's definitely a very large trend. And at Microsoft, we spend a lot of time helping our customers with cloud transitions. That can happen both with infrastructure as a service and with platform as a service. We definitely see both, and both are quite successful if you do them correctly. The interesting part is that it actually changes quite a bit of the subtleties about how you build an application to perform well or to behave well. And you have to kind of start by understanding sort of what is the main difference. It's not just that you're running your application somewhere else. You actually want to consider how you design your application to take advantage of the environment in which you're running. That can sometimes mean whether or not your application succeeds or not depends on whether you make those choices, or whether or not it's cost efficient to do the move is really about that mindset of, am I going to go learn this environment and see how it can help me, rather than just assume that it'll be exactly identical to what you had built in your bespoke data center environment for your custom application. So the first thing to keep in mind is it's someone else's computer. You didn't choose the specifications on it. It didn't really, you can choose which one you're picking, but often it's not going to be an identical match to what you have on premises, and it's not going to be a perfect fit to what your application needs. So you may need to go and tweak how your application is built to be able to take advantage of different hardware and tune for it. Another big area is the network. You often don't control the network. In many cases, custom applications in your own data center just have one top of rack switch between your app tier and your data tier. That often is not the case in a cloud provider. You often have to go through 2 or 3 switches in order to get from there from here to there, and that means that chatty applications will often notice that. Furthermore, when you're renting the computer instead of buying the computer, the way that you think about how you use it is different. For how do you make sure you use it efficiently? So if you have an application that's only really used, say 9 to 5 during business hours, you can turn it off at night and save money in this world. Whereas in the CapEx model of when you buy your own computer, you would have that computer and you've already kind of had that sunk cost that you have to deal with. Last main thing that I've seen is just the role of what a DBA is has been morphing. There's a lot more focus on tuning and management of applications at scale rather than sort of handling one big database on your own. You get a lot of things for free in SQL Azure, for example. You get automatic backup, automatic upgrades, automatic security patching, etc. Encryption on by default. There's a lot of things that are just handled for you that used to take a lot of time to design and implement properly. These days, you don't have to do any of that for the most part. You just have a little bit of clicking on a website and then you're done. So the general trend that we see is shifting a lot towards tuning and figuring out how to improve an application's performance, either just by improving the time it takes to do operations or figuring out the least cost way to implement the solution that you need. And there's been some interesting consequences of that. Now, SQL Azure today, the singleton version, doesn't have resource governance. And so a lot of on-premises behaviors that you would maybe take as sort of religious dogma, like rebuilding indexes, isn't always necessarily the case that it's a good idea in the cloud. That doesn't mean it's always a bad idea or anything like that. But I posted a somewhat controversial Stack Overflow topic where I basically said, unless you really, really need it, don't bother, because the size of data operations were often causing customers to have escalations where their 24/7 live sites, their 24/7 sites were just going down because the rebuilds were taking too much load and blocking customer traffic. So you need to think through what are the trade-offs on how you use this, because the environment is not one that you own. So when you kind of go into how the application gets designed, you need to make sure that you're resilient to the concept of running on this somewhat different hardware. Usually that means that you have to build retry logic into your application to be able to handle a failover that happens due to a machine failure or some other reconfiguration event that happens in the cloud, because it's often possible for those to happen during business hours. There's been a lot of work on moving towards custom maintenance windows and trying to minimize the number of these that will ever happen in an application, just to simplify the life of an application developer. Similarly, there's been logic being added into the client drivers to do automatic retries in a number of cases, so that there's even fewer cases you have to worry about application logic like this. But you still probably need to handle it, because machines do fail and you need to be able to recover quickly. And that's often a good property of a modern application. I mentioned briefly earlier that there's been this trend towards maybe using get put patterns in some cases. And so there's definitely a number of customers that ask about microservices and how that works into an application. And it can be good. Definitely, it can simplify what logic you're storing in the database. It can also have some interesting challenges in terms of what type of performance you can get, or what kinds of optimizations you can or can't do in each part of your application, including the data tier. So I'll talk about that next, I believe. No, actually, I have that in a, yep, here it is. So I have a number of cases where I've been called in to do escalations with customers, the bad kinds, where they've basically gone through this journey. They're like, hey, I've heard about these microservice things. Everyone's doing microservices. I should probably do a microservice. That seems like a really good idea. So you can talk to them all day and explain that there's good and bad. They're like, no, I want to do microservice. I'm like, okay, microservice it is. And then they've already decided, you know what? I'll have a microservice for each entity. So a customer, microservice. Order, microservice. If I want to do customer join orders, that basically means microservice 1 pulls out customer, microservice 2 returns back a JSON document of all the others, and then you try to manually join them in the app tier. And so this usually leads down the path of, I really don't want to think about databases at all. I just want to store JSON blobs. And then I'm going to store a whole lot of them. And I've had more than a couple of the escalations come to me of this general pattern where by the time they get to me, they've either got many hundreds of gigabytes or terabytes of JSON blobs stored in the database. It lets you store JSON. It's not that it's wrong to do so. However, it's nowhere near as efficient as trying to store things in a schematized fashion in a relational database system. So NoSQL systems often work fine because they only accept JSON in many cases or similar, and then they will only allow you to do a certain class of simple operations that they've optimized. If you want to do the same kind of thing in SQL, you typically would want to put it in regular columns because that's where all of the optimizations are for, using efficient joins or using indexes, etc. So this shows up in funny different ways. I had one customer running on SQL Azure who asked for multiple replicas so they could try to do read scale out. We do support read scale out today on SQL, but in this case, they were trying to do something like, I think they wanted 15, which was not something that we test or support. But that gives you a sense about how far down the path they had gone before they had really realized that maybe they weren't designing it right. We've also had a customer that decided that using Hekaton, our in-memory OLTP engine, would be a great idea because that might make JSON parsing go faster. And the answer is it will go maybe a little bit faster, but not enough to overcome the fact that JSON is still radically slower when you're trying to do any large-scale processing on it versus just doing a regular relational model. So I have one big ask for you today. Please don't let your friends do this pattern. I don't really like going to these escalations because often the customer and maybe the director in charge of this does not like to hear the message that I have to give them that they're going to have to redesign their app in order to make it work well. And that usually is something where someone doesn't want to admit that this was a bad idea. So I see these patterns regularly, and I'll just say it's okay to use microservices. It's okay to use JSON. Just make sure that you understand the full scale of what you're doing and do performance tests up front to make sure that you can get whatever you need to handle the load, because these design choices seem like they're great ideas up front, but they often fall over at scale. And that's really the challenge for a lot of our customers who maybe haven't worked on large scale applications before. So I mentioned that there were 24/7 applications. This is also a general trend. There's a lot of services. Obviously, Microsoft has a whole bunch of services. Customers on top of our Azure platform also run 24/7 applications where a customer can go in at any time of the day and get access to their software as a service application and then figure out, it has to work. So we have a number of those that are built on SQL, and there's other things that are built on, say, Cosmos DB. You see this all the time. There's no downtime. So there becomes a very large premium on being able to go take what you can do whatever you can do to maybe avoid locks or size of data operations or downtime. So there's a lot of patterns that we see to try to make that better in terms of just how you evolve your schema. There's also various scenarios for how you can avoid locks or minimize the customer visibility of long running operations to make them less of an impact to a business where you maybe have an SLA on your uptime. Last trend we see is that especially when you had a large server, it was always easy to add another database on SQL Server, and therefore it made sense to just kind of, okay, add another database into the server, and we've already paid for it, we might as well use that. However, that often led to very tight coupling across many databases, and thus it's hard to sort of refactor and rethink a database as you grow it. So ultimately, thinking through, can I take certain kinds of data and move it into a different database in my application if they're not really talking to each other that much? That trend is also happening for a number of good reasons. It lets you think about using the scale out hardware that's available in clouds, because you don't necessarily have to have a giant machine. If you can take your 10 databases that we're running on maybe an HP Superdome and then run them on more commodity hardware, if you can just put them on 10 different servers instead, that means that you get to focus on what you really want your application to do for each part of your workload. And it also can simplify, well, when I need to do an upgrade of something, do I have to upgrade the whole big thing, all 10 databases, or can I just do one at a time and maybe minimize the visibility of when customers see that? Both of these kind of go together, and I think they're definite trends that we see on people trying to coordinate how they build their applications to avoid super tight dependencies whenever they're trying to do upgrades. In fact, we've been adding a whole bunch of features over the past several years to try to support the notion of low downtime or low lock duration so that you can minimize the visibility of any maintenance operations that you want to do when you have to do them. So obviously we added online index build many releases ago. We added that for column stores not so long ago in 2016. We've been doing things like making more alter column operations be quote unquote online, or shall I say, mostly minimum locking. We've got per partition rebuild to try to minimize the time for large databases to do different operations like rebuild or reduce stats. We do the same thing, kind of go further than that and say, okay, if I want to allow failovers in the middle of an index rebuild, then we now have resumable rebuild for B trees. And that's a neat operation because if you have a long running operation where you're doing an index build or rebuild and there's a failover, historically that would mean you'd have a long time to kind of get the database back into a consistent state before you could even connect again because you'd have an outstanding transaction that was very long that needed to be rolled back. Well, now with SQL Azure and SQL 2019, you can use accelerated database recovery, which means that you keep versions of the old and new pages in memory, in the database, I should say, until the transaction completes. And separately, the resumable part allows us to go and do mini commits in the middle so that we can get closer and closer to finished. And even if there's a restart or failover, then we can just resume from the place where we last took a checkpoint rather than having to start and rebuild the whole B tree again. So both of these mean that you have the option to kind of split up the duration and the impact of doing maintenance operations like index build if you have the need to do so. And continuing with the same theme, we did wait at low priority, so you can have lots of operations that you know are sort of secondary to a user workload, but you just want them to try to finish at some point. So you can say, well, I don't know how much load I'm going to have from my users, but maybe you can try this operation, but wait at low priority and kill it if there's a lot of user workload so that I don't have any impact on my site. And then you can just retry it later. I mentioned accelerated database recovery. That is on by default in SQL Azure. It's not on by default in SQL Server at this point, but we do recommend that customers with 24/7 type applications strongly consider enabling it if it can help their application there. And then we also recently have added into SQL Azure, it's not yet into a version of SQL Server, doing asynchronous stats rebuild with wait at low priority. And we actually did that based on an engagement with one of our big internal customers, Dynamics, that runs on top of SQL. And I'll talk a bit more about them later. But this helped them to reduce some of the downtime that they were seeing impacting their customers on some operations where queries were not performing as well as they wanted. So all these different things that we've been building over the past few years are directly a result of customer feedback. And we go and validate whether these are working by going and talking to customers, including our first party ISV partners, to make sure that these can help visibly improve the quality of the services that they're able to provide. So here's an example of how modern applications are doing online schema operations and changes. So if I have an existing stored procedure that's doing an update on a table, I might have my statement, including, update table, call one, call two, call three, and then whatever the rest of the statement is. And if I want to add a fourth column into that table, I want to make sure I do that without causing a size of data operation on the alter. The typical way that you try to do that is you just make sure that it is nullable, and then you add it as null, and semantically that it makes sense for call 4 to be null, even while my Sprock v1 continues to run with updating call 1, call 2, and call 3. Then once you've finished adding the next column, you want to go and roll out another stored procedure version for your application, which I called my Sprock v2 in this case. And you can see here it has the ability to see call 1, call 2, call 3, and call 4. The next thing that you get to see there is that, okay, when you switch over, you may not necessarily have every part of your application switch over at exactly the same moment. Let's say your application tier has 10 servers in it. You may need to roll through each of those and switch them over to the new code one at a time. And that means there'll be a period of time where maybe some are using MySprock v1 and some are using MySprock v2. So you need to have some semantic intent around what null call 4 means, and it needs to work through both versions of those applications while they're being rolled out. And then obviously, once you finish moving all of your application tiers over, you can get rid of MySprock v1 And then you can potentially go do operations in the background to fix up what null call for means if you need to finish your schema change. So these types of operations, if you think about them cleanly ahead of time and test them to make sure that you don't have long-lived locks, you have the option to reduce the downtime and impact on your customers. You also need to be careful. Not every kind of schema change is possible in this world, but if you're careful about which ones you're trying to do, you can avoid long downtime operations. So another trend that we see, and this one maybe isn't quite as visible because it just sort of creeps up on you a little bit, is that there's obviously an explosion in the amount of data that we see in the world these days. We added column stores in SQL 2012 for the first version, although it wasn't necessarily the most useful back then. We've developed it over multiple releases, and now you can store lots and lots of data in a single SQL Azure database or SQL Server database. And it's not uncommon to have SQL Server customers try to store 100 terabytes or more at this point of raw data into SQL. And that would have been considered ridiculous 10 years ago, just not even possible. You would redo how you think about your data warehouse to have a coarser grain in your fact table just to try to get that time to do a scan of your fact table to be lower. Now, these days, you still may have some of that, but a lot of customers are just keeping all the data and then processing it in the background. And really, we have a whole trend towards just more and more data. There's also some regulatory requirements that kind of impact how long you have to keep data. In the United States, for example, we have this regulation called HIPAA, which is a healthcare law, and you often have to keep data for 7 years. And so that means that often a lot of application designers will just keep it in the main database, and I keep it in a backup database just to kind of keep the main database backup times low. But overall, you will see customers trying to do things like using our temporal table feature, which has two tables underneath the covers, and they can have the main table be a B tree with regular indexes on it, and then the history table can actually be a column store. Since it can be compressed, that can save a lot of space and also make it simpler for them to understand the queries. If you're just querying the main data, it won't touch both tables. However, if you need to do a report over the whole table, including the history, then you can do that. And so customers do things like that to try to minimize the amount of time it takes to do a backup and to simplify their query application design in their app by just allowing us to use modern SQL features in the later versions of the SQL standard. Just as a call out, there are functionalities in the column stores which only exist there. In cluster column stores, we have the ability to compress blobs, and that can be a huge space savings for a lot of existing applications because we don't do that for normal B trees at all. And then furthermore, there's actually two levels of compression. There's a flag you can say for archival, which really means it takes more time to compress, but it's better in terms of smaller on disk space versus the normal compression that we have. And if you can use those, then that can definitely take what used to be a really, really big database and make it not quite as big, meaning that you obviously don't have to do as much in terms of maintenance, and the query times are often okay, even on very large data sets once you do that. The next thing that I see for these trends is that because we have done a lot of investments on batch mode and column stores and making it easier to process data at scale, it used to be that you would have to really think about how you design the schema for a data warehouse. Like Kimball has all of this, different types of data warehouse dimensions and how you can describe them. And it's been great to make sure that you can build highly performant, well-tuned data warehouse queries. However, we also have a trend for people just taking a bunch of raw data and shoving it into a column store and figuring out, well, maybe I'm not optimal, but it was really easy to kind of get some value out of this data instead of having to go through a whole design pattern to get SQL to understand all the different facts and dimensions and to do that transform. You can often just run queries on a column store, and it can be quite useful to get some value out of it, even if it's not quite as optimal as a perfectly tuned solution. And then finally, obviously, we continue to make heavy investments within Microsoft on batch processing to try to make those queries go faster, and we'll keep doing so. So it's not an area that we're forgetting. So I was just pondering while I was writing this talk how different the world is than the time that I maybe first started at Microsoft. We have done all these investments here, and now the size of what you can put on a single database machine is massive. And even going further than that, right, we have scale out systems that we've built, both in terms of SQL Data Warehouse / Synapse SQL and even hyperscale that are now able to store across many, many machines, and you can store up to a petabyte or more in some cases in these systems to get really just very, very large raw data that you can process and actually get value out of. So the great part about SQL is as you decide what kind of problem that you want to solve for these very large database problems, you can pick the right storage technology, and it's all based on the same core stuff underneath the covers, these column stores in batch mode. We just add more layers to it to give you that scale that you need. So if you want to do scale out and all of these column store types features, it's all just there. And you can use the same general language that you're used to with SQL. One of the things that we had to kind of learn how to do with a lot of customers, and we do this actively today, is to really work with customers that are trying to figure out how to tune their application about how and when they do that. Because when you have a bill every month, it really changes sort of your incentive on what you can do, right? Sometimes if you take an application and decide to go and invest in tuning queries, you can run in a smaller reservation size, and that directly means that you can save money and maybe be more profitable for whatever it is that you're trying to do. Similarly, if you have an application that has variance in its requirements over the course of the year, you don't necessarily have to use the old model, and you can tune differently. So traditionally, if you go back 10 plus years, your model for buying servers would be you'd kind of figure out whatever your transaction rate is on your server, and then you'd figure out what your growth rate is for the next 3 years. Then you'd put in a fudge factor, maybe double it. Then you'd go buy that server and you'd pay for SQL licenses and the hardware and all of the power and things to run it. And then you would run your code, and maybe you wouldn't bother tuning it until you got to the point where you were starting to run out of headroom on that server. And we would often get customers coming to us desperate because they wouldn't be able to tune fast enough to fix things once they got close to the boundary of what the machine could do. And they couldn't buy a new machine fast enough to migrate to that. So in the cloud, you have a lot more flexibility, but it also means that you need to be a bit more responsible all the time around this so that you can optimize your costs. This gives you a chance to say, okay, well, if I've got a busy holiday season, like we're about to go into holiday shopping season and Black Friday and all of that, and obviously there's a whole lot of online sales that'll happen this year and many every year. So you can say, okay, well, I don't have time to go tune my application right now, but I do have the ability to scale up. So I might, increase the number of cores that I assign to this database that's taking online orders to make sure that I don't run out of capacity. And then maybe I can just record what I think are the most expensive hotspots in my application so that when it comes time for February, when maybe sales aren't as big a deal, then you can go back and try to tune that application so that you can figure out how to reduce your load. And you can also obviously scale back down after the holidays. So each of these is now a lever that you can pull in terms of what do you want to do? Do you want to scale up and pay more right now, or do you want to tune and save money? And the most efficient and effective companies we've seen doing cloud transitions have invested a lot of time in this to figure out how do they go take advantage of this opportunity, because it's not a natural thing for a lot of existing companies that have not gone to the cloud yet. So if I had to give you one piece of advice in this talk, go learn how to do query tuning, because it will help you to be able to help people save money. And that's a huge thing that almost everyone will need in the world where they use cloud hardware. Last major trend that I want to talk about here today is related to what we see with how you can use cloud hardware in new ways. We have customers on premises who do this pattern, sharding, but what you do in the cloud is historically, before we had hyperscale, you would hit some size limit on the database and then you wouldn't necessarily be able to add more stuff. So if I have a giant customers and orders table, it's actually safer in the cloud to split that up across multiple databases because those end up being on different machines. And that means that if I have a server go down in my on-premises world, I don't take any orders. However, if I can spread the load across a whole bunch of different servers and one of them goes down, well, I don't lose as much money during that time period if a failure happens. So building query patterns for sharding means you have to think about the schema and whether things are within a shard or they have to cross all shards. And typically you want to either avoid crossing all shards or assume that that's going to be some longer latency batch kind of operation. We support functionality like Elastic Query and Elastic Jobs to be able to do shard management and to give you the ability to take these fleets of similar schema patterns and do things like count up the number of orders you had in a day across all the shards, for example. But those are not intended to be interactive queries in the same way that maybe you're used to with queries that are just against a single database. However, your main OLTP workload, where you're going through and trying to take an order and commit that transaction, that works just as fast as before. The only real difference is you don't want customer one touching customer two's stuff, which is actually a good property in many of these systems. You just have to formalize that in terms of how you build your application pattern. We did work in the last couple of Seek releases to make row-level security available, which lets you kind of implicitly add the where clause from this particular slide. So you can say, hey, whenever I connect to the database, I want to say that I am customer 5, and then you can obviously have implicit filters that would say where customer ID equals 5 to make sure that you're filtering down just to what the customer should see. And that often can simplify how do you think about the application design pattern, because all the queries against that table can get that added automatically if you want. So we've done some work with some of our SaaS providers to basically adopt that pattern and help increase the focus on, I want to talk to just this subset of the data when I'm doing queries within a database or a shard. And then other operations, maybe I can decide if I want to do a report over all of them to handle those as exceptions rather than making both sets available in the same database. So once you get into building ISVs, there's a lot of really interesting incentives and trends that we see that happen. Usually in the old model, an ISV would sell a copy of their software, and if it ran on SQL, someone would buy a copy of SQL to go along with it. They'd set up 2 servers and run their local copy of their software licensed thing from the application vendor, and then a copy of SQL, and they would tune each of them and make them both work. Whenever you start getting to the point where you're now hosting those in the cloud, often the ISVs are becoming SaaS providers, and they just give you a web portal and you go connect to it. And the very first ones would just go sign up the same pattern that they saw before for on-premises, but they quickly realized that in many cases they could actually start doing things like consolidating the app tier, so they don't need one app tier per customer because maybe they don't really have that much going on. They can spread that across multiple customers and be more efficient. And similarly, they eventually get to the point where they figure out, well, how can I share resources across the data tier as well? Because it's not expensive, it's not cheap to run databases. So how can you make sure to take the best advantage possible of what's there? Like, so we've added features like sharding. We've added features like elastic pools and hyperscale, which lets you do certain kinds of consolidation. And what we've ended up seeing is once they start doing this, they realize, oh, wait, I can save a ton of money because I don't need 100 different app tiers. I can just have 10 servers that handle my 100 customers. And then they get to the next point where they realize, well, even if I wanted to buy like 1 core per customer, not all of them are busy at the same time. So I don't necessarily need 100 cores. I might be able to get away with 10 or 15 cores in the data tier. How do I do that? And then I can just increase and decrease that over time based on the usage of my service, and I can try to save money for my SaaS service. So the high level idea that we see there is if you have 100 of something going on, then tuning it becomes 100 times more valuable. And we see that in spades with a lot of the larger ISVs that have done this SaaS migration. And the pattern for doing it is not radical. It's, the query store is there since 2016, and it gives you the ability to go get a good capture of the different things that are happening in your workload. And then you can look at the hotspots and figure out which things are candidates to go hint or tune or otherwise improve. Sometimes you rewrite the query. Sometimes you improve the physical database design by adding an index. Sometimes you just need to add a hint to make sure that the optimizer gets nudged in the right way. But each of these levers is there for you to try to figure out how do you go reduce the overhead of a query and thus be able to actually improve the performance of the application or the cost of the application. One of the things that may not be obvious to people that you have to do, especially when you're using someone else's hardware, is there definitely can be cases where maybe the ratio of one resource to another in the cloud hardware doesn't line up with the desired ratio in an application. Often, especially in on-premises environments, we'd have customers that had extremely beefy TempDB systems. They would run, in-memory drives and other fancy things that were super fast. And when they move to cloud hardware, that doesn't exist. You're just running on SSDs in most cases there. So that picture led to stress where maybe you had applications that were really heavy on TempDB, but they maybe so much that they couldn't scale. So they end up not being able to get all of the money savings they want by doing overbooking and consolidation until they go and reconsider how they solved certain problems in their app or how they use the database. So, for example, we've done a bunch of work with ISVs to try to say, okay, your application is maybe TempDB heavy, but you're not memory heavy. So, what can we do to maybe use more hash joins and less TempDB? And then once you get the balance of the application right, then you can better take advantage of the cloud hardware and make sure that you minimize the amount of money you have to pay. So this type of thinking means you have to go look at what are the different resources that we're using and how am I bound on this particular application. So we usually provide a lot of guidance to customers on this to try to work with them to smooth out their application and get the best performance possible. I also will call out that as of 2016 and beyond, we've been basically putting the optimizer changes underneath the database compatibility level. And the reason for that was to try to minimize the risks of upgrades causing performance problems. Meaning, if you upgrade from SQL Server, say 2016 to 2019, and you stay on the 2016 compatibility level, you usually will continue to get the same query plans in most cases. And that reduces the risk since you can't go back to 2016 once you upgrade. At least the database file format is not downgradable. So when you get into that picture, you want to minimize that risk. So we say, okay, the actual point where the new functionality now turns on is the compatibility level. And many of those features are specifically intended to help reduce the CPU or otherwise reduce your costs when you use them. So we do actually encourage customers to test with the new compatibility levels and see if it's possible to leverage them. We try really hard not to introduce breaking semantic changes in the compatibility levels anymore, both because we run a cloud service using the same software and because customers don't like changes like that. So whenever we can avoid them, we do. So you still have to test for those to make sure that you're okay on any given upgrade. We don't change semantics on every single compatibility level, but we do change the compatibility level for every major release of SQL. So some of the newer functionalities, such as batch mode on Rostore that we added in the last release, can be a substantial gain for some customers. Interleaved execution, where we will run certain operations ahead of time and then split up a query into two parts so we get better cardinality estimates. Memory grant feedback has also been great for repeating query workloads to make sure we tune how much memory we reserve for each execution. So that often lets us get better throughput by allowing more queries to run at a time once we learn how much memory you actually need for a given execution. All of these things kind of go into the trend of now we're into the query performance tuning game, and if you can do it well, you can save a lot of money. So I'll talk through a few examples now. One of the customers that we've worked with the longest actually is Azure DevOps, which was formerly called TFS. And they have run on SQL Azure from the early days. In fact, they were the first quote unquote ISV. I use that term loosely. It's not an independent software vendor, but we treat them the same in the sense that they're a platform built on top of SQL. And so it's a first party ISV is the way I think of it. But we work with them. I have a regular weekly meeting where we go through and talk about different issues and design points in their application and how we can try to make SQL work better for them and how they can better use SQL. And so it's been a great engagement. Initially, they started off as a single tenant model and then eventually realized they would go multi-tenant. And they have about 1,000 databases or so worldwide. Don't quote me on the exact number, but it's enough databases that it's a lot. And they have millions of customers. So it's a very big service, and anyone can go to the website and go get themselves a workspace, and that gets stored inside of a SQL database. So they do a lot of really interesting things around cost tuning because they do have a free tier, and thus they've got a lot of sensitivity to costs. So, for example, they have a piece of software that we call a bot, and it goes through every day and looks at the usage of each of their databases and says, hey, this one is not using that much CPU. This one is. Maybe I can scale up or scale down individual databases to try to make sure that I'm not overpaying for databases today. And so they do that, and that saves them a ton of money. They run it automatically because obviously testing 1,000 databases is not a task you want a human to have to do every day. So they've built software to automate that. This particular application also was fairly TempDB heavy back in the early days, and we've done a lot of work with them to figure out, okay, when do you really need TempDB versus when can we leverage memory for hash joins or other types of things like adding more indexes to avoid needing to have TempDB for spools or sorts. And once we started getting into that game, we've sort of tuned it with them over the different generations of hardware that we've added to our service. This particular customer actually was a great example for the batch mode on row store feature. When they moved to Compat 150, it got them about 15% savings for chunks of their application because we were able to make some bigger queries run a lot faster by using the batch mode functionality on the larger queries. So doesn't mean that every single application will get that same kind of savings, but please consider, especially if you have queries that return a lot of rows, batch mode is far more efficient than row mode for being able to process those. So you'll find that testing that would be well worth your time. So I have a weekly meeting with this team, and we go through and look at all the different patterns. In fact, we were working on one just yesterday during business hours, trying to figure out why a particular piece of functionality in their service was taking longer than we thought. And we were doing some really interesting debugging to see, okay, is it this? Is it that? And that engagement usually leads to us adding features and functionality or supportability capabilities into SQL that benefit all of our customers. So we do these types of engagements regularly to make sure that we're finding good customer patterns that we see in the wild with regular customers outside of Microsoft, and we help make sure that we try to focus on the ones that have the best bang for the buck for all of our customers. Another example customer that I'd like to talk about today is Dynamics 365. So Dynamics Online, as it was formerly called, used to run their own fleet of SQL servers in Microsoft data centers, and they would host them, and customers would go and pay, and you can get customer relationship management software or an ERP planning piece of software, and there's a lot of large companies that use their stuff. So they run on top of SQL, and they've recently completed a transition to SQL Azure over the past 2 years. And we work with them very deeply to kind of go through and see, okay, what types of things can we do to help Dynamics improve the experience for their customers, to use SQL the best way possible. How do we make SQL better for Dynamics' needs? And there's a lot of things that we learn from them because they have hundreds of thousands of databases. And that leads to a lot of challenges, right? If you have hundreds of thousands of anything, then any problem will show up probably on hundreds of databases. So we end up seeing pretty much any problem you can have in our service, we see by working with Dynamics, and they give us a great sense of what the good, the bad, and the ugly are that we have to be working on to improve. Whenever there's something that's a challenge in our service, we go work with them and make sure to test out, okay, can we mitigate it? Can we fix it? Can we validate with you that you fixed it? And we work with them on what are the things that take the most labor for them to fix in their application working with their customers. They have a team that does specifically query tuning for their customers because customers can build roughly their own schemas and their own kinds of query patterns in Dynamics. And so they don't have homogeneity of all the different types of queries that are run. And as a result, they have a big need to make sure that each of their customers are getting tuned performance. So they've done a lot of investment in trying to use our automatic indexing features. They use the query store extensively and the automatic tuning functionality. We've added things into query store to try to help make sure that Dynamics has all the knobs they need to kind of work at big scale and small scale for all the different kinds of customers that they see. They used to have to go create plan guides, and I don't know if any of you have ever tried to create a plan guide, but one of the reasons why when we did the query store, we tried to make it really easy was that plan guides worked, but they were hard to set up and they were flaky. You had to be really precise in terms of exactly how many 2-byte UTF-16 characters were in this SQL string and where does it start and where does it end, and making sure you got that right was just a pain. And now with the query store, you just say, take this one in the UI and click force, and it's done. So a lot of the labor work that we've done with them to try to reduce the cost for them to do something, either by making it quicker and faster to mitigate issues for their customers, or by doing work where they can get the benefit of an automatic functionality that just does it for them. That whole space is a huge opportunity for us, and we continue to make lots of investments to try to make this easier for them. Both because we know it helps Dynamics, and it also happens to be the exact same problem that we see with the average customer when they're trying to tune. Maybe not everyone has a query expert on their company's payroll to be able to get the advantages of what we're doing here. And our goal is to make it so it's easier and easier to get good behavior by default by just using SQL, and the rest we make more and more automated for you. Dynamics uses Elastic Pools to try to figure out how to minimize the amount of money they have to pay on SQL because they're obviously so big, they have to do this, and they work on optimizing their CPU load with us, just like we did with TFS. They were an early adopter of the accelerated database recovery feature that I mentioned earlier because they were able to measure for some of their customers that have maybe not so modern patterns where they were really doing big transactions and causing failovers by accident. This meant that they were getting downtime because we had to run recovery on the database before we could bring it back online. And obviously, if you're a SaaS provider, that's not desirable. So we have been working with them to use accelerated database recovery to make sure that that downtime for a failover is usually much, much lower, just a few seconds at most. And that has been a great benefit for the Dynamics business because we were able to bring that to them. So we work with this team to evaluate all the different issues that they see with their LiveSite work. And then we use that to kind of turn back around and figure out where can we go work with SQL Azure and SQL Server to bring features and functionality that works better for our customers out of the box. ISVs also typically have a weird pattern that kind of goes into how you tune and how you think about things. So both TFS and Dynamics have this sort of exponential pattern where there's a few giant customers and maybe you put them in a shard by themselves. And then there's a whole pile of not so giant customers that maybe you group together into databases or pools to be able to overcommit to the resources and figure out how you right size the actual CPU assignments that are there. So as an example, TFS has, or sorry, excuse me, Azure DevOps now has two different giant customers. One of them is essentially the SQL team, and the other is the Windows team. And we run far beyond what the average customer would use in terms of requirements. We have thousands of engineers on each team. Then you have smaller teams that don't need as much, and you can group those together. And figuring out how to find those and tune differently for them actually is also a common theme that we see for a lot of these ISVs that have robust business models. So when you're designing for a sharding pattern, please keep in mind that you probably will have a need and a desire to keep those customers that are giant in their own place because they might need different kinds of query plans for those applications to perform well when you have 3 orders of magnitude more data or more usage than the average case. So to summarize some of the types of apps that we see built using modern patterns today, these are just first-party ones that we spend time with. I have a lot of third-party ones as well, but these are ones that kind of give you a sense of the kinds of patterns that we work with and that we recommend to customers when they're considering transitions to modern application architectures. Azure DevOps, as I mentioned, they have millions and millions of customer workspaces with this exponential pattern and a few giant tenants. They also like to run hot, so they run as high as they can on CPU and then tune up and down based on how things are going. So the nice part about that for the SQL team is it's like having a 24-hour a day stress test running all the day on 1,000 databases for us. So they find if there's any issue that exists in SQL, they find it for us really quickly, and then we can go work with them to get it fixed. And we test with them heavily to make sure that happens extremely rarely. SharePoint Online is another one. It runs in Office 365. They also use SQL extensively and have sort of the same general design pattern, multiple tenants per database. And they also use Elastic Pools. And we're doing a lot of work with them on improving the overall cost of how they run their business, the same similar way that I mentioned with DevOps and Dynamics. Dynamics actually has multiple different workloads that all fall underneath the Dynamics 365 family, and they mostly all run on SQL. So we have interesting challenges because of the query patterns that happen out of each of them, and also just due to their sheer size. They have so many databases at this point that we have to sort of think statistically about how do we attack the problems that they see so that we can try to get the best bang for the buck for the improvements that we can make. And then we have another customer that I'll mention. Bing runs their ad serving layer, and then they kind of have a reporting infrastructure for that so that all the customers that are buying ads can go see, okay, how many people saw my ad and how many people clicked through and that sort of stuff. So they use a giant set of, I think, 100 or so databases all running column stores, and it's all a heavy analytics workload. And it does the same general approach as what we've seen in these other patterns today. But overall, the interesting part about them is that they're not just doing an OLTP application. They're actually doing heavy analytics and reporting using exactly the same patterns and techniques. They just have to use column stores, batch mode heavily, and then make sure that they manage the size of those databases to deal with that. So these are all examples of what you see that I would call modern application patterns. And if you want to go and make sure that you're moving your business model forward, this is the way that we do it at Microsoft, and is how we recommend our customers when they're working with us to do the same. So I promised I would talk a little about what happened in a pandemic. The first is you end up working from home a lot. You can see my office here. I have been getting to talk a lot on different conferencing softwares, from Teams to Zoom to whatever. It's been great in some ways that we can all keep working and talking to each other, even in these trying times. It's also been challenging because sometimes it's easier to do things face to face than what you would ordinarily be able to get done on a remote connection. So whenever things locked down, I got stuck at home here and I was not able to go travel for work. And whenever this happens, Microsoft does this kind of thing happens. We usually will have like a daily meeting across all the different teams in Azure and make sure that everything that we can do to help our customers is being done. And at the time that that was happening, obviously everyone was moving to work from home, and that led to massive spikes in usage for some of the virtualization services and collaboration software that we have. So Teams and Windows Virtual Desktop specifically both had massive spikes in usage. And whenever this happened, we hadn't been doing direct engagements with either of these teams in any major way like we did in these other groups that I mentioned in the talk earlier. But I sort of set out a feeler and said, hey, if anyone wants to talk about making sure the performance of your app is okay on SQL, please just let us know. And sure enough, within the next day, I started getting inquiries from different teams, and we got to go sort of figure out how to make things work for them. Teams in Italy, there was an actual article published on this, that they had a surge of 775% increase in the workload there. And that was huge, right? That obviously breaks most designs. You don't typically do stress tests for that. Windows Virtual Desktop, a lot of people needed virtual desktops, and there was also similar load increases there, where every week they were trying to double in size. And the great part about cloud hardware is as long as you have it, then you can make sure to grow cloud hardware and scale up until you can handle things. But if you get these kinds of increases, often you would need to figure out what to do, because if you run out of whatever bigger machine you can go to, then you need to talk to someone. And I kind of, sad to admit, but I sort of enjoy when these kinds of things happen, because usually that means we get an opportunity to go work on helping a customer that's in stress and try to see if we can make them feel better. So we went and worked with these first party teams to try to make sure that each of their database applications worked okay. We did not have any engagements really with them before like we do elsewhere, but when we started getting into them, the types of problems that they see were the same kinds of problems I see with a lot of customers that do similar kinds of escalations whenever they have a business model that takes off. They had cases where they really had just done a code first model and written some link queries and not really double checked that things performed very well. And whenever the size of the table started getting big, then all of a sudden the fact that you're scanning on things instead of doing a seek was really killing their application. Similarly, adding indexes here and there would selectively make workloads perform orders of magnitude better. The temp table issue that I saw earlier, we had that kind of problem in spades as well, where people were just copying things into temp tables needlessly because they were just using that as an application design pattern. So getting people to think about, well, do you really need that here? Is it actually because you want your performance to be specifically tied to that temp DB, or some other reason? Maybe you were just doing it because that was how everyone else did it. And we saw patterns like that. So the typical anti-patterns for what you'd see for normal SQL workloads were showing up in all of these that you hadn't tuned. And then finally, resizing databases works great up until the point where you can't get a bigger one. And so for a lot of these customers, the main impact they had was the CPU was spiking to the top of whatever we could sell them. And then doing things like sharding would be a rewrite. So we'd have to work with them on, okay, how do we get you enough time to be able to shard this application so that you can scale it out across multiple databases? And usually these types of performance tuning tricks and techniques are there to help us give them that time. So in the span of 2 or 3 weeks, they would often pivot their application design, get the new version out there, and then hopefully their application would keep working. And so for the most part, after we kind of got to a more stable spot, we were able to get each of these applications to a better place. And so um, I guess the other comment that I'll make is for all the other big services that we've been working with regularly, they didn't really have too many issues. Now, granted, they weren't getting 3 to 10x load factors, but they had already done all the work to do the tuning so that they were in a position to be able to respond, and they had all of the playbooks in place. So the takeaway that I'd like to suggest for you is that doing this type of homework upfront in your application, where you're constantly just doing the investments to tune and tweak and double check the performance of your application is optimal, really does help whenever you get to one of these discontinuous events. You end up with the opportunity to kind of look at it without the panic of, hey, everything's failing and my boss is staring down my neck. What am I going to do about it? So please, whenever you get to the opportunity of investing in your application when you're running on cloud hardware, please do so, because it usually pays off, especially on the bad days. So I hope that we can obviously get to do this again, but we're getting to the end of the talk, and I just wanted to say thank you to everyone.